You start, sir.
Yeah, okay, sir. Yeah, good morning, children. We're discussing the lesson regarding the periodic classification. Once again, we remind the topics whatever we have discussed earlierly. Periodic classification. Yes, we have completed Dauber-Renner law of triads, as well as we have completed Newland's law of octaves. After that, Mendeleev classification. Then mostly modern periodic law based on atomic numbers. After completion of that, yes, we have seen blocks, how they have classified, and how many groups, how many periods are there, and what is the general electronic configuration that have completed. And based on the electronic configuration, the modern periodic table, the long form of the periodic table is constructed based on the atomic numbers, and as after that we have classified based on that electronic configuration. So in previous lesson in atomic structure, we well known about Pauli's Hund's principle. Based on that, we will fill the electrons in the shells and subshells. That was clearly explained. Once again, we will go through with the configuration right now. You can see here, from the first shell onwards, along with shell S, we are going to see the configuration right now. If you will see here, first we are going to fill electrons in 1s. The capacity of the subshell will be, here it is what? The capacity of the subshell will be, yes, subshell, it is 2 electrons. After that, if we will see, we are starting from the top onwards and it is ending at the arrow itself. After that, again we have to start from 2s, from the top onwards, the second line. After that, 2p6, then 3s2, then it is ended here. After that, 3p6 and 4s2. So like that, the number of electrons which is awarded for the atom, we are going to fill the electrons based on this principle. This is called as Euler diagram. Based on this diagram, we are going to fill the electrons like this. In a similar manner, what? Initially, 1s2 first of all, 2s2, 2p6, 3s2, 3p6, 4s2. Like that, continuously, we are going to fill the electrons in this manner itself. Okay. So it is the filling of electrons in the respective elements. Based on the electronic configuration, the new periodic table is constructed. Then after properties of the elements, periods and groups. Already we have seen physical properties, atomic radius, ionic radius, ionization enthalpy. These are the topics are pending, and now we are going to discuss about this. Before going to discuss about this, electronic configuration is completed. Now, valence electrons. So what are valence electrons and what is valency? The difference between valence electrons and valency now we are going to see. First of all, valence electrons, we will observe. If we will see here, in a period, the number of valence electrons increases from 1 to 8, from the left to the right, and the number of shells is in the same itself. Once you observe the second period in the periodic table classified by the Mosley, long form of the periodic table. So if we have seen in the second period, the elements are continuously lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, and the respective atomic numbers from 3rd to 10 itself. If you are going to write the electronic configuration as per the Euler diagram, what he has given, 1s2 and 2s1 itself. After that, beryllium contains 1s2 and 2s2 itself. After that, 1s2, 2s2 and 2p1 of boron. Like that, the configuration is increasing with an single electron in the same subshell. Children, once you observe in this period, if you are going to observe the things, lithium to neon, here itself, 1s2, 2s1 is the configuration for lithium, and the neon configuration is 1s2, 2s2 and 2p6. That means the electron lithium, the valence core electron is present in the second shell, that is 1 electron as 2s1. Similarly, neon, if you are going to observe 2s2 and 2p6, that means the 8 electrons are present in the second shell. Here in lithium, 1 electron is present in the second shell. By means, it represents what? The shell number is same. Okay, whereas lithium contains second shell core electrons, and as well as neon also contains second shell core electrons. So whatever the number of electrons which are present in the valency shell, that is means last shell. చివరి కక్షలో ఏవైతే ఎలక్ట్రాన్స్ అయితే ఉంటున్నాయో వాటిని మనం valence electrons అని చెప్తున్నాం. The number of electrons which are present in the valency shell that are generally called are valence electrons. That are called are valence electrons. Once you observe in lithium second shell 2s1, that's why how many number of electrons are present in that? 1. Like that in beryllium 2, boron 3, it is going to enhancing, that is increasing by 1 unit of electron. Shells you are going to observe in lithium second shell, beryllium second shell, see shells here itself. Whereas if we observe here, generally valence electron is 1, in beryllium 2, 3, 4, it is going to increase up to 8. But shell will be, see once you hear shells, second shell, second shell, second shell, everywhere second shell only. That means what we are going to observe in the period, the shell is not changing, but number of electrons are going to enhancing by 1 unit of electron. ఒక్కొక్క ఎలక్ట్రాన్ పెరుగుతుంది ప్రతి ఒక్క ఎలిమెంట్ కి పీరియడ్ లో. ఇది regarding the period itself. By means what we are going to observe here, in the period the valence electrons are going to increase by 1 unit, but the shell will be same. That is, he has given the number of shells is the same, but the valency electrons are increases from 1 to 18 itself. Now in a group we are going to observe. So first group we are taking, in a group the number of valence electrons is the same for all the elements, but the number of shells increases from top to bottom. పైనుండి క్రిందకి మనకు గ్రూప్ కనుక అబ్జర్వ్ చేస్తే what he is going to say, valency electrons is the same for all elements. అంటే number of valency electrons are same. By means what, sodium ki 1, hydrogen ki 1 electron ఉందనుకోండి valency electron, valency shell లో number of electrons, and lithium also having 1 electron, sodium also having 1 electron, and potassium also having 1 electron. So this indicates what, the number of valency electrons are same in the group, particular group itself. Now once we are observing the first group itself, what is the first group? We know that alkali metals itself. So in this alkali metals, if you are going to observe here, hydrogen is the first element in the first group. This is hydrogen. Okay, in the next element in the first group is lithium, after that sodium, after that potassium. Atomic numbers once you see, hydrogen atomic number 1, after that lithium atomic number is 3, after that sodium atomic number is 11, then the potassium atomic number is 9 here itself. Then electronic configuration, if you are going to observe of first group elements, here we are going to get 1s1 of hydrogen, 1s2, 2s1. Already we have seen lithium here itself 2,1, here is also 2,1. Sodium if you have taken 1s2, 2s2, 2p6, that's why in second shell we are having 8 electrons. After that in sodium if you have taken 3s1 is the valency electron. Similarly potassium if you have taken here 1s2, 2s2, 2p6, 8 electrons, 3s2, 3p6, 8 electrons, and 4s1 will be the valency electron of potassium. Everywhere you see observe 1, 1, 1 and 1. By means it represents what, the number of valency electrons down the group is same. That means what, చివరి కక్షలో ఉండేటటువంటి నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ అనేటువంటివి ఆర్ సేమ్ ఇన్ ద గ్రూప్ ఫ్రమ్ top to bottom itself. But whereas in period what, it is increases. But shells, the same shell is present in the period. But whereas if you observe the shells, in first shell 1 electron, in second shell 1 electron, third shell 1 electron, fourth shell 1 electrons. By means what we are going to observe here, finally the valency electrons in the groups are same, whereas the valency electrons in the period increases from left to right, but the shells in the period is same. The shell will be same in the period, but whereas in the group the shells are going to be increases by element to element from top to bottom. So this is the major thing we have observed in the periods and groups, how the valence electrons are varying in the groups and periods. So next topic, if we will going to discuss about the next topic, atomic size. The trends in atomic size is given. First of all, students, what is the atomic size? First of all, asal atomic size ante enti? Generally, atomic radius is the distance between the nucleus and the outer edge of the electron cloud అని చెప్తున్నారు. Generally, most probably చాలా మంది చెప్తా ఉంటారు ఏమని, the distance is in between the nucleus and the valence shell is called as atomic radius. Generally we can call. So the actual definition is not like that. కేంద్రం నుండి పరమాణువులోని కేంద్రకం నుంచి చివరి కక్ష వరకు ఉన్నటువంటి దూరాన్ని పరమాణు వ్యాసార్థం అని చెప్తా ఉంటారు జనరల్ గా. But it's not the correct one. The actual definition we should give what? Atomic radius is the distance between the nucleus and the outer edge of the electron cloud. That means nothing but కేంద్రకానికి మరియు చివరి కక్షలో ఉండేటటువంటి ఎలక్ట్రాన్ మేఘానికి మధ్య ఉండేటటువంటి దూరాన్నే పరమాణు వ్యాసార్థం. That's nothing but what? Atomic radius is the distance between the nucleus. See, once we here observe everyone, this is the nucleus of one hydrogen atom. Here we are having H2 molecule. Okay, children, you can observe only one hydrogen. Don't take two hydrogens. We are saying only regarding the atom. We are discussing only regarding the hydrogen atom itself. So what? Here it is the nucleus of the hydrogen. This is parabanu yokka kendrakam. Ee kendrakam nunchi this nucleus onwards, the distance what we have up to the electron cloud. Once you observe here everyone, that bluish color shade which it is present up to at which level? Up to that place. Probably it is almost equal to the valence shell, right? Because the electrons which are present in the valence shell up to that place we are taking the cloud. చివరి కక్షలో ఉన్నటువంటి ఎలక్ట్రాన్ మేఘం వరకు మనం తీసుకుంటున్నాం కాబట్టి అందరూ కూడా అప్ టు ద valence shell అని చెప్తాం. But we have to take the electron cloud. So from the nucleus to this electron cloud, up to the electron cloud, whatever the distance is present, that it can be called as atomic radius of hydrogen, we can call itself, right? So in this manner we are going to define the atomic radius. And this atomic radius, generally we have any fundamental quantities are having some units. We know that very well. Yes or no? If any liquid is there, if we want to measure it, we can measure in liters or milliliters. Similarly, the distance, this can be measured in meters. Yes or no? Or centimeters. By means what? Where it is really very small distance itself, we are going to measure in the form of what? Picometers. What is that? Picometers. We are going to measure the atomic radius in generally in picometers itself, right? So hydrogen picometer is 30 picometers. Hydrogen atomic radius is 30 picometers. Like that, oxygen 66, nitrogen 70. Right? Some of the examples: fluorine, chlorine, bromine, iodine, like that. It was given clearly itself. Okay. So generally here also one more picture also we have here. Distance between the nucleus. This is called as atomic radius. Only from here to this nucleus to at this edge where the atom is going to sharing with another atom. It is going to contact with another atom up to this valency level. So up to this valency level, the distance in between the nucleus and the up to the electron cloud, it can be called as atomic radius itself. This is the nucleus of another atom. This is not a single. This is not a total single atom itself. It is what? A single atom of hydrogen, a single atom of hydrogen. If we have considered, this can be called as the nucleus. From the nucleus to the valency shell itself. Okay. So this is about the only the definition of atomic radius. Paramanu vyasardhaniki sambandhinchiనటువంటి నిర్వచనం మాత్రమే ఇది. That means what? The atomic radius definition only itself. The distance between the nucleus and the outer electron cloud, outer edge of the electron cloud. It can be measured in the picometers itself, right? Okay, children. After that, now we are going to discuss about atomic radius. Already we have the definition. We have the definition of what? Atomic radius. But now, along with atomic radius, some different radiuses also will be present after formation of some bonds. With the different atoms are forming in the bonds, or ions are forming in the bonds. So based on that, how can we define those radiuses? Once we will see. Let's. First one is what? The metallic radius. What is that? The metallic radius. What is the metallic radius? Once we will see. The metallic radius is half of the experimentally determined distance between the nuclei of nearest neighbors in the solid here itself. So what he is saying, once clearly observe the children here, the metallic radius is the half of the experimentally determined distance between the nuclei of nearest neighbors in the solid. Where if you are observe here the two diagrams, if the two solids are in the bond, that is what in the metallic bond. Okay, two solids are in which bond? Metallic bond itself. If the distance from here to here it is r, that means first radius from it will be here to here it is r, and as well as from this nucleus to the outer large cloud will be r. The total distance in between these two nucleuses can be what? 2r itself. Okay, if you are taking that, if these two are in a metallic bond, rendu kuda లోహ బంధంలో గనక ఉన్నట్లయితే అప్పుడు ఉండేటటువంటి వ్యాసార్థాన్ని మనము లోహ వ్యాసార్థంగా చెప్పుకుంటాం. దట్ ఈస్ కాల్డ్ యాజ్ మెటాలిక్ రేడియస్. In the sense what? Half of the distance only we need to take it as. The total distance is not. The half of the distance means from here to here the total distance. The half of the distance where two are in metallic bond, that half of the distance can be called as what? A metallic bond, metallic radius itself. That means what? If the two solids are in metallic bond, the half of the distance which is experimentally determined between the two nucleus, రెండు కేంద్రకాలకి మధ్య దూరంలో సగాన్ని తీసుకోవాలి మనం ఇక్కడ. అంటే ఈ 2r, ఈ న్యూక్లియస్ కి మనకు డిస్టెన్స్ ఎంత? 2r వచ్చేసింది. మరి దీంట్లో హాఫ్ ఎంత? r అవుతుంది. That is what the metallic radius is. Similarly, if you have taken second one is the covalent radius. What is covalent radius? The covalent radius of a non-metallic element. ఇక్కడ చూడండి, మెటల్స్ కనుక బాండ్ లో ఉంటే మెటాలిక్ రేడియస్ అంటున్నాం. మరి ఇక్కడ మెటల్స్ తీసుకోవట్లేదు. మెటల్స్ అంటే సాలిడ్సే కదా. ఎవ్రీ మెటల్ ఈజ్ ఇన్ a solid state except mercury, that we know very well. After that, the non-metals are nothing but probably gases. So the covalent radius of non-metallic element is half of the experimentally determined distance between the nuclei of nearest neighbors in the solids itself. ఇక్కడ ఏం చెప్తున్నాడు కదంటే నాన్ మెటాలిక్ ఎలిమెంట్స్. సో ఇఫ్ యూ హ్యావ్ టేకెన్ ద నాన్ మెటాలిక్ ఎలిమెంట్స్ హియర్, వాట్ we are going to say, if these two are non-metallic elements, those are in bond, these two are in a bond here itself. At that time, which bond? It is a metallic bond. First we have seen a metallic bond, but here we are going to observe it is a metallic bond. Because of that reason it is a metallic radius, half of the distance. But here is also half of the distance, but these two are in which bond? These two are in completely, these two atoms are in completely which bond? Covalent bond itself. That will be covalent bond lo unnappudu the half of the experimentally distance in between the two nucleus, in between the two nucleus, here clear it, in between the nuclei. So ee nucleus ki madhyalo unde half of the distance ni avi covalent bond lo unnappudu must and should these two are present in covalent bond itself. The half of the distance between the two nucleus which are covalently bonded, సంయోజనీయ బంధంలో ఉండేటటువంటి రెండు పరమాణువుల మధ్య దూరంలో సగాన్ని సంయోజనీయ వ్యాసార్థం, that is covalent radius. Okay, this is called as covalent radius. Then after that, now we are going to discuss about what the ionic radius. Children, we know very well when ionic bond is formed, when covalent bond is formed, when metallic bond is formed. Ionic bond formation is nothing but definitely two ions are required. One is cation which contains a positive charge, one is anion which contain a negative charge itself. So in between the two different type of charged particles, that is charged ions, a bond which it is going to be formed, that it can be called as an ionic bond, like MgCl2, NaCl, like that. But that once you will see the ionic radius of an element is related to the distance between the nuclei of neighboring cations and anions. So what he is saying, the ionic radius of an element to the distance between the nuclei of neighboring cations and anions itself. Once you observe, children, here half of the distance everywhere we have taken, but whereas here itself what element is related to the distance between the nuclei of neighboring cation and anions. The distance between the two nucleus of a cation of a anion. That it is two must and should. Those are two bit. Definitely ion should, not metals. Sorry, not atoms without having charges. Okay, atoms are nothing but what? A neutral atom, if we will take that, it's not called be ionic radius. Definitely ion should be present. Then only we can define it as what? Ionic radius. If we will see ionic radius of O2 minus, it will be what? 1.40 angstroms it will be. What is the ionic radius of Mg minus 2? Measure MgO distance is MgO and subtract 1.0 he has given. So that calculation we'll see later itself, because exactly based on the values of the magnesium and oxygen ionic radius, easily we can calculate itself. So once again we will see the metallic radius, covalent radius, ionic radius. So initially we have discussed what is first of all atomic radius, then after metallic radius with the half of the distance between the two solid metal particles, half of the distance between the two nucleus. So half of the distance between the two nucleus which are covalently bonded. The distance between the two ions of different charges is called as ionic radius. రెండు వేరు వేరు ఆవేశాలు కలిగినటువంటి అయాన్ల యొక్క కేంద్రకాల మధ్య దూరాన్ని అయానిక వ్యాసార్థంగా మనము చెప్పుకుంటున్నాం. ఓకే, right. So the first topic is the first property in the periodic classification, that is atomic radius definition is completed. Now how the atomic size or atomic radius మనం ఎట్లా మెజర్ చేస్తామో కూడా చూసినాం. యాంగ్స్ట్రమ్స్ లో చెప్పొచ్చు, పికోమీటర్స్ లో అని చెప్పినాం. యాంగ్స్ట్రమ్స్ లో కూడా చెప్పొచ్చు, పికోమీటర్స్ అండ్ యాంగ్స్ట్రమ్స్. ఇట్లా చెప్పుకుంటూ పోతే అటామిక్ సైజ్ కి యూనిట్స్ అనేటువంటి వచ్చిన తర్వాత ఈ అటామిక్ సైజ్ మరి ఇప్పుడు వ్యాలెన్స్ ఎలక్ట్రాన్స్ చూసినాం. ఎట్లా how we have seen the valence electrons? Valence electrons in the groups continuously it is similar from top to bottom, but whereas in the periods the valence electrons is increasing by 1 unit of electron. Yes or no? Similarly atomic size, how it is increasing or decreasing in the groups and periods. Why it is increases and why it is decreases? Let me know once. In a period, first we are going to observe the period. So what happened in the period of atomic size? Once we will see. In a period, the atomic size of the elements decreases from the left to the right because the nuclear charge, number of protons increases, and so the electrons are pulled closer to the nucleus itself. Same చెప్తున్నాడు. Children, once again clearly listen. In a period, the atomic size of the elements decreases. Atomic size period లో left నుంచి right కి ఏమవుతుందంటున్నాడు? It is going to be reduced. That means decreases, తగ్గిపోతుంది left to the right because the nuclear charge increases, and so the electrons are pulled closer to the nucleus. పీరియడ్ లో ఎడమ నుండి కుడికి పోయే కొలది పరమాణు వ్యాసార్థం అనేటటువంటిది క్రమక్రమంగా తగ్గుతుంది అని చెప్తున్నాడు. ఎందుకంటే కేంద్రకం యొక్క ఆవేశం అనేటటువంటిది నెంబర్ ఆఫ్ ప్రోటాన్స్, ప్రోటాన్ యొక్క సంఖ్య పెరగడం వల్ల, ధనావేశం పెరగడం వల్ల ఈ రుణావేశపూరిత ఎలక్ట్రాన్లు ఏవైతే ఉన్నాయో దోస్ ఆ రుణావేశపూరిత ఎలక్ట్రాన్లు అనేటటువంటివి కేంద్రకం చేత పూర్తిగా ఆకర్షించబడుతున్నాయి. దట్స్ వై దీస్ ఎలక్ట్రాన్స్ ఆర్ కమ్ క్లోజర్ టు ద న్యూక్లియస్. It means what, children? Completely the atomic number increasing in the sense number of protons increases. Atomic number is equal to number of protons kada. So atomic number increases means what? Number of protons are increases. By means positive charge increases. When positive charge increases, at that time there is an attraction force. That's we know general thing. Attraction force between positive and negative charges will be there. Where positive charge increases, the negatively charged electrons which are present in the elements are completely attracted by the or pulled by the positively charged nucleus. Because of that reason, what will happen? The shell is completely pulled towards the nucleus. Because of this pulling, the shell is somewhat coming closer towards the nucleus. Because of that reason, what will happen? The electron cloud is coming more towards the nucleus. Once see here, if hydrogen nucleus is here, if the electron cloud, generally it is present here. Because the positive charge increasing, the electron cloud here it will be present actually. When it is pulling towards the nucleus, this last shell will be moved somewhat closer to the nucleus. By means it is somewhat closer to the nucleus. That means the size will be reduced or not on by increasing the atomic number. So because of that reason, from left to right, the atomic size in the elements is going to be reduces. Once you observe the example, second period, here we are taking lithium to neon. We know the atomic numbers, An is atomic number, 3 to 10 is atomic number. And electronic configuration, we know that 2, 1, 1s2, 2s1 to 1s2, 2s2, 2p6, 8 electrons are there. Number of protons increasing, I said. Yes or no? Number of protons, how many? 3 in lithium, atomic number. So number of protons are equal to atomic number. Number of protons 4, 5, 6, up to 10. So here it will be what? Number of protons increases. Protons nothing but what? Positive charge. While positive charge increasing means this positive charge is pulling the electrons which are present in the electronic configuration or not. So these electrons is pulled by the 3 protons. These electrons are pulled by the protons. Similarly, every element positive charge is completely pulling towards the nucleus. Because of that reason, the valence shell electron cloud which is present in the valence shell, that is coming towards the nucleus. Because of that reason, actual size kante kuda somewhat the size is going to be reduced. So the distance already we have discussed, atomic size nothing but what? The distance from the nucleus to the valence shell, that is going to be reduces. Okay, right, fine. Next, in a group, the atomic size of the elements increases from top to bottom. So children, once you observe, group లో పై నుండి క్రిందకు వచ్చే కొలది అటామిక్ సైజ్ ఏమవుతుందంట? పెరుగుతుందంటున్నాడు. How it is possible? So atomic size of the elements increases from top to bottom because the number of shells increases and the distance between the nucleus and shells also increases. Students, I think you are getting a doubt. Sir, here also number of protons increases and here also number of protons increases. Yes or no? Here number of protons increasing and here also number of protons increasing. But why only here the protons or the positive charge are pulling towards the nucleus? Once you observe here, along the period, it is the electrons are filling in the second shell only, but the protons are increasing continuously and the shell number is same. These electrons, valence electrons are present in the second shell, everywhere second shell only in the second period. But whereas in the group, once you observe, atomic number is 1. The valence electron is present in first shell and the valence electron present in second shell, in this third shell, in this fourth shell. By means what? The protons number here is also increases as like the period. But what? The shell is same in the period, but whereas in this group, the shell number is changing. Ikkada రెండో పీరియడ్ లో రెండో షెల్ లోనే ఎలక్ట్రాన్స్ అన్ని ఫిల్ అయిపోతున్నాయి పీరియడ్ లో. కానీ గ్రూప్స్ కి వచ్చేసరికి చూడండి, ఫస్ట్ అటామిక్ నెంబర్ హైడ్రోజన్ కనుక అబ్జర్వ్ చేస్తే వ్యాలెన్స్ షెల్ ఫస్ట్ షెల్ అవుతుంది, లిథియం లో సెకండ్ షెల్ అవుతుంది. బై మీన్స్ సెకండ్ షెల్ చేంజింగ్ మీన్స్ ద డిస్టెన్స్ బిట్వీన్ ద న్యూక్లియస్ అండ్ యాజ్ వెల్ యాజ్ ద వ్యాలెన్స్ షెల్, దట్ మీన్స్ ద ఎలక్ట్రాన్ క్లౌడ్ డిస్టెన్స్ ఈజ్ ఎన్హాన్స్డ్ ఆర్ నాట్. Even though here it is also the positive charge attraction force, it is also positive charge, here also the positive charge is pulling the electron cloud, but whereas the distance is more or not, here 10 positive charges are there and the second shell is pulled, 9 positive charges are there, second shell is pulled. Number of protons increases everywhere, second shell is pulling by the positive charge, but whereas number of positive charges are increasing, at the same time the shell number is variation. That means the shell number is also increasing. So that means the distance is increasing. Even though the pulling force is there, but somewhat it is less. Where the distance is increasing, the pulling force is working somewhat very much less as compared with the period. కేంద్రకం యొక్క ఆకర్షణ శక్తి వ్యాలెన్సీ షెల్ అనేటటువంటిది పెరిగే కొలది దాని యొక్క ప్రభావం ఉంటుంది, కానీ మరి అంతగా పీరియడ్ లో ఉన్నంతగా ఉండదు. Because of that reason, what will happen? The atomic size, the distance from the nucleus to the valence shell, which is present of the electron cloud, that is going to be by element to element from top to bottom completely, it is going to be increases. Atomic size is going to be increases. So the final thing what we are going to observe, the students once again clearly observe, we have discussed the atomic radius as well as Ionic radius, metallic radius, these are all we have discussed. But what finally we are knowing, majorly the atomic size or atomic radius is completely reducing in the period from left to right and atomic size is going to be increases from top to bottom in the groups. This is the final thing we will learn in this slide. Okay, after that, okay, so already we have seen what in the trends in physical properties. We will be studying about atomic radius. So see, observe this atomic radius, ionic radius, it is completed. Next, we are going to see about what metallic property, which it is not present in that metallic property. We will see. Let's see metallic property. Okay, children. What is metallic property? First of all, లోహ స్వభావం అంటే ఏంటి అసలు? సో మెటల్స్ ఆర్ డిఫైన్డ్, మనం మెటల్స్ ని ఎట్లా డిఫైన్ చేస్తున్నాం? Metals are defined by their ability to give up electrons and form cations. For example, sodium, if we have seen, we have the configuration of sodium what generally? Sodium, see, 11 electrons are there. Once, 1s2, 2s2, 2p6, 3s1. So in the last shell, how many electrons are there? Only one electron is present here. But in the second shell, 2s2, 2p6, by means octet configuration is present or not? So octet configuration, it is giving the stability to sodium. Because of that reason, sodium, which are having one electron in the valence shell, third shell, it is ready to lose the electron very easily. So for sodium, what it will do? By losing of this one electron, once you observe sodium, 2 and 8 only it is having the configuration. By losing the electron, sodium will get which charge? Positive charge. So by losing this one electron which is present in the third shell, sodium is getting the configuration of 1s2, 2s2, 2p6. That means second shell having only 8 electrons, which is giving the octet configuration and stable configuration to the sodium. So because of that reason, it will ready to lose the electron. So metals are defined by their ability to give up the electrons and form cation. By losing the electron, sodium is getting which charge? Positive charge. So because of that reason, it is forming a cation. Metallic property decreases across the period and increases down the group. Once you observe the students, if you observe the electronic configuration of the periodic elements, period elements, once again we'll see. Period elements, once you observe, everyone, here lithium, 1s2, 2s1, 2s2, 2s2, 2p1, 2s2, 2p2, 2s2, 2p3, 2s2, 2p4, like that up to 2s2, 2p6 is there. Up to here what, if you are going to observe 2s1, 2s2, 2p1, 2s2, 2p2, by means what, clearly the last shell electrons are moving towards the octet configuration. Once you observe the second shell, octet we got or not? -1 octet, -2 octet, -3 octet, by means these are all the electrons are trying to get the octet configuration in the valence shell. So because of that reason, these are the period elements will not show the interest to lose the electrons easily. From here onwards, if you are going to observe generally. So 4 electrons are there, for example, in the valence shell of carbon, 2s2, 2p2 in the format. More 4 electrons is given to the carbon, what will happen? It is getting octet configuration. So what it will do? It try to gain the electrons. Nitrogen also try to gain 3 electrons. By losing of 5, it is very difficult. Gaining of 3 is easy. Because of that reason, it will gain the electrons. 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 But metallic property is defined as what? Gaining of electron is not the property of metallic property. It is a non-metallic property. So మరి ఇక్కడ non-metallic property increase అవుతుంది తప్ప metallic property increase అవ్వట్లేదు కదా. So along the period what will happen? Metallic property is going to be reduces. Okay, but non-metallic property ఏమవుతుంది? Increases. Lithium, it's ready to lose. Why? Because one electron is gone. Completely fulfilled orbitals are present in that. That is what S shell capacity is to 2 electrons are present in that. If those 2 electrons are lost, beryllium also getting. So metallic property here it will be what? Up to here it will be increasing. But after that what? It is going to be what? Beryllium, boron, after from nitrogen onwards, it is going to be non-metallic. Metallic properties decreases. Non-metallic property is going to be increases. Non-metallic property is nothing but gaining of electrons here itself. Once you observe here, this is a group elements. First group elements. 1, 1, 1, 1. Easily it can lose the electrons. By losing means metallic property, getting a positive charge and forming a cation. Hydrogen will lose the electrons, will form H plus. Lithium will lose the electron, Li plus, Na plus, potassium plus. But the removal of electron. Nothing but losing of electron is easy in hydrogen or potassium. You know, students, hydrogen electrons this side is here, potassium electron this side is here. Potassium electron loss of easy. Why? Because the nucleus is present here. This is the first shell. This is the second shell. This is the third shell. This is the fourth shell. We can remove the electron easily from the fourth shell. It also readily lost the electron from the fourth shell. Why? Because the nucleus attraction force is less in the valence shell of fourth shell. But whereas nucleus attraction force is more. Why? Because beside of the nucleus only first shell is present. But whereas these many shells are present. First, second, third, after that fourth. So it can remove very easily. So one example I'll tell you. One magnet you can take some iron one by one beside of the magnet you can keep. If you want to just remove the iron nails from the attraction force of the magnet, one by one 4 magnets if you kept, which nail you can remove easily with a small stick or with a normal force. Normally just you are touching that. The last nail which it is present, which it is far away from the magnet, that we can remove easily or not. Similarly, the last electron, if here the magnet will be present here, these are the iron nails you can consider. Which nail you can easily remove? This nail easily we can remove. Why? Because the magnet force will be less upon the last nail. Similarly, the nucleus attraction force is less on the last electron. So directly it can removed a less force and easily it can lose the electron when compared with the hydrogen. Because of that reason, potassium will get the metallic property very easily. That is easily lost the electron when compared with lithium and sodium. Because of that reason, in a group, what is going to be happen? The metallic property increases down the group, whereas the metallic property decreases across the period and increases down the group. Similarly, if you observe the non-metallic property, it is opposite to that. Why? Because in the group, we require electrons in order to get that. Non-metallic property increases across the period and decreases down the group here itself. Okay, so atomic radius and metallic property. See here itself, sodium and magnesium, aluminium or metals, silicon and phosphorus are metalloids. Metalloids in the sense what? Which have the both property of metals and non-metals. రెండు లోహ స్వభావము అలోహ స్వభావము రెండు కనుక ఉంటే కనుక వాటిని మనము మెటలాయిడ్స్ అని చెప్పేస్తాం. నాన్ మెటల్స్ ఆర్ వాట్? సల్ఫర్, chlorine, argon. This is the third period elements. In a period, metallic property of the elements decreases from left to right. In a group, metallic property of the elements increases from top to the bottom. See here itself, carbon, silicon, germanium, tin and lead. So carbon is a non-metal. Silicon is a metalloid. Germanium is metalloid. Tin is completely a metal. Lead is completely a metal here itself. Why? Because the distance between the nucleus and the valence shell, especially it is impact. The major impact is what? The distance between the nucleus and the valence shell. Because of that reason, we can explain the metallic property, how it is going to be vary in the groups as well in the periods itself. So finally, we can know that as what? Electropositive nature also we can call it. Why? Because by losing of the electron, that element is getting which charge? A positive nature or not? So this is called as electropositive nature. Either the electropositive nature or metallic property along the period from sodium to argon or any period from left to right, it is going to be decreases. In the group, it is going to be increases. Similarly, non-metallic property, if you have taken, non-metallic property is increases. See, here it is a metal, but coming to the last, these are non-metals. So finally, we are going to get non-metallic property increases or not. Similarly, if you are going to observe carbon, silicon, germanium, tin, lead, fourth group elements, non-metal to metal it is coming. So metallic property is increased, but non-metal initially it is there. Finally, we are not observing the non-metal. So because of that reason, initially it is a non-metal. Finally, non-metal is not there. So non-metal property is going to be reduces in the groups, whereas metallic property is going to be increases in the groups. So once again, observe children, metallic property increases in the groups, metallic property decreases in the periods. Non-metallic property increases in the groups, non-metallic property decreases in the periods itself. Okay, So this is regarding atomic size, ionic radius, covalent radius, metallic property, non-metallic property, valence electrons we have discussed. Next, the other physical property once we are going to discuss about, that is what? Ionization enthalpy. అయనీకరణ శక్మము అంటాం తెలుగులో, లేదా అయనీకరణ శక్తి అని చెప్తారు. So here, how can we define ionization enthalpy? First of all, what is the definition? Once you clearly observe here, a quantitative measure of the tendency of an atom to lose an electron is given by its ionization enthalpy. So what he's saying, a quantitative measure of the tendency of an element to lose an electron is given by its ionization enthalpy. It represents the energy required to remove an electron from an isolated gaseous atom. X is its ground state. In other words, the first ionization enthalpy for an element X is the enthalpy change delta H for the reaction. X is in gaseous state. He is going to give X plus is in gaseous state plus an electron. So children observe clearly. And I'll say in Telugu first of all. After that, I will explain in English. Why? Because most of the children are making a call. If possibility is there, let explain in once Telugu also, sir. That's why. Okay. So generally గా వాయు స్థితిలో ఉన్నటువంటి ఏదైనా ఒక ఒంటరి పరమాణు నుంచి తటస్థంగా ఉండాలి, న్యూట్రల్ గా ఉండాలి. న్యూట్రల్ ఇన్ ద సెన్స్ వాట్, దెర్ ఇస్ నో చార్జ్ అపాన్ దట్. వన్స్ యు సీ హియర్, వాయు స్థితిలో ఉన్నటువంటి గ్యాసెస్ స్టేట్ లో ఉన్నటువంటి ఒంటరి తటస్థ పరమాణువులోని the last shell from the valency shell, వాయు స్థితిలో ఉన్నటువంటి వాలెన్సీ కక్షలో ఉన్నటువంటి చివరి స్థాయిలో ఉన్నటువంటి ఎలక్ట్రాన్ ను తీసివేయడానికి కావాల్సినటువంటి శక్తినే అయనీకరణ శక్తి అని చెప్పేసి చెప్తున్నాం. అండ్ దట్ మీన్స్ అగైన్ the definition what we are going to give, the energy which is required to remove an electron from an isolated gaseous atom. వాయు స్థితిలో ఉన్నటువంటి ఒంటరి తటస్థ పరమాణువు యొక్క చివరి కక్షలో నుండి ఎలక్ట్రాన్ ను తీసివేయడానికి కావాల్సినటువంటి శక్తినే అయనీకరణ శక్తి అని చెప్తున్నాం. For example, one gas is there. For example, chlorine is there. Chlorine is which is in gaseous state, or oxygen which is in gaseous state, or nitrogen which is in gaseous state. From the gaseous state neutral atom, there is no charge present upon that. So from the gaseous state atom, to remove an electron from the valency shell, valency shell నుంచి ఎలక్ట్రాన్ తీసేయడానికి, రిమూవ్ చేయడానికి, the energy which is required to remove an electron from the valency shell of an isolated atom in its ground state. Other words, that means what? Initial definition we have given IP1. So similarly, after that also we can remove IP2, IP3, IP4 like that. So the general definition is what? The energy which is required to remove an electron from an isolated gaseous atom in its ground state is called as ionization potential. In other words, the first ionization enthalpy for an element is X అనే ఒక ఎలిమెంట్ తీసుకుందాం మనం ఇక్కడ. That is, which is it is in which state? It is in gaseous state. That's why in bracket, once you observe children, X it is given G, that is in gaseous state. We are going to give some energy to remove an electron from the X element. When we have removed the electron from the element, X is changed as X plus cation. So while the removal of electron, X is converted as what? X plus. By removal of electron, any element will get which charge? That we know well. That is what? Plus. That is X plus cation, which is in gaseous state, and the electron which is removed, that we are going to write as plus E minus. Okay. So this is called as IP1 or IPE1. Why? Because ionization potential energy 1. One way we are calling, just we have removed only one electron. That's why it can be called as IP1. It's it. After that, if you are going to observe, next point, the ionization enthalpy is expressed. Already we have discussed. Atomic radius is going to measure in angstroms, otherwise picometers. Those are the units. Similarly, this ionization energy is the form of energy. It is always positive. Why? Because we are giving the energy to the atom. Its energy is not releasing here. Energy is absorbing by the element. That's why it is taken as positive. So it is also the form of energy. The ionization enthalpy, which is energy also called it as enthalpy, is expressed in units of kilojoule mole inverse. Why we are giving kilojoule mole inverse? Per mole, how many kilojoule of energy is used? That is the meaning of that. So we can define the second ionization enthalpy. This is called as first ionization enthalpy. Why we are calling first ionization enthalpy? From the neutral gaseous atom, if we have removed.
Sir.
Okay, sir.
Please kindly close the session, sir, by 10:40.
Okay.
Okay. Thank
you. Okay, sir. So ionization enthalpy, second electron, if you are going to remove that it can be called as what? From the X plus, here we are taking whatever X plus we got here, the mono positively charged cation, from that positively charged cation, again one more electron we are going to remove. That is what? X plus gaseous state positively cation, from that we are removing one more electron, that can be written as plus E minus, and the second positive charge, here we are going to get X plus 2 itself. Okay, so in this manner, this is called as first ionization energy and this is called as second ionization energy. Children, already I told you, take one example of magnet and iron nails. How it will be there? One magnet we are keeping at first one place and electrons are one by one we are keeping. First electron we can remove easily, which is far away from the magnet. But whereas the second nail, if you want to remove, it was somewhat difficult. Why? The magnet attraction force is working when compared with the last nail, it is more on the second nail. Why? Because it is somewhat closer to the magnet. Now, similarly, if you want to remove the last electron, it is easier. But whereas the second electron, if you want to remove, the electron is getting attracted by the nucleus more and more. Because of that reason, we have to use some more energy than the energy which we have used earlier. ముందు యూజ్ చేసిన ఎనర్జీ కంటే కొంచెం ఎక్కువ ఎనర్జీ యూజ్ చేయాల్సి ఉంటుంది. కాబట్టి సెకండ్ ఎలక్ట్రాన్ తీసేయడం అనేటటువంటిది కొంచెం ఎక్కువ ఎనర్జీ అనేటువంటిది మనకు రిక్వైర్మెంట్ ఉంటుంది. బికాస్ ఆఫ్ దట్ రీజన్ ఆల్వేస్ the second ionization potential energy is greater than first ionization energy, and similarly third ionization energy is greater than second ionization energy. Like that, every increasing, if you will say, second is greater than first, third is greater than 2, and fourth is greater than 3. Like that, the next ionization energy is always greater than the previous ionization energies. Energy is always required to remove electrons from an atom, and hence ionization is always positive. Okay, sir. Right.
Thank you, sir.
Right, sir. Thank you, sir. Thank you, children.